If I load the Rich Text Box demo, this form allows me to load up a rich text document, which I've already created, using WordPad in Windows. And here I can do things like select some text and choose a font. There we go. I can choose a font size. We can choose a color. Here we are. We can zoom in and see more or less of the document. Zoom in, zoom out. And all of these are happening because of controls on a tool strip control. Well, let's look at how these controls are working. If I bring up the form, you'll see our combo boxes within the tool strip. Let's start with this one. Let's look at its properties. There's an items property that allows me to add items to the combo box. And I've added these items, and of course I could add items dynamically at runtime as well. Once I choose one of these, the selected index changed event occurs, and here you'll see what the code's doing. I create a float variable to store the zoom factor, and I get the text out of the combo box. We're going to strip off the trailing % before parsing it out, and we'll use the try parse method. I mean, it's going to work because we put the numbers there, but just in case, we'll use try parse. We'll put the result into zoom, and then we'll create the zoom factor, which is the zoom amount divided by 100, a percentage. We set the zoom factor of the rich text box to be that amount. Then we set the focus back to the rich text box. How about this list of font sizes here? Again, we have here in the items property a collection of font sizes which I created. You could dynamically add others if you like. This is just a hard-coded list for now. And in this combo box, we're going to add items programmatically. So let's go to the code to see how we're adding those items. Here in the load event handler for the form, I'll look at the add fonts procedure. And the add fonts procedure just does standard graphics handling of fonts. We create a new graphics object, or we retrieve the graphics object from the form, which gets us information about the graphics context we're working in. And now we can call the getFamilies method of the font family class to retrieve a list of all the font families. And for each one of those, we'll loop through, add the name property to the items collection of the font family toolstrip combo box. If I look at the modify selection font procedure, this is the procedure that gets called whenever we change the size or the font name of any font. And unfortunately, fonts work this way. You have to actually create a new font every time you want to modify any behavior of a font. So here, the first thing I do is retrieve the current selection font of the text box. That gives me the font of the current selected text. Now I'll get the text from the combo box and store that in new name, and the size from the font size toolstrip combo box and store it away. I'll set the style to be 0 and the char set to be 0 for now. And if the font is null, if I couldn't retrieve a font, for example, if I had multiple fonts selected, font will be null. If that's the case, I'll assume we want a regular font style. Otherwise, if it wasn't null, I'll get the style of the selected font and the character set of the selected font and store them into variables. Now we need to deal with the fact that not all styles support regular or italic fonts, and so we'd look to see if a style is available within the selected font, and this is stuff we don't need to talk about right now, which is dealing with determining what font style to use. Finally, we create a new font object based on the name you selected, the size you selected, the style, we're using points as a measurement, and the character set of the selected font, and we set the selection font equal to the font you selected from the tool strip. We set the focus back to the rich text box when we're done. There's not much else going on this tool strip that you haven't seen before. For example, if you select the bold item here, it just toggles a format. Let's go look at that procedure. Toggle format gets the selection font. If it's not null, it sets the selection font and creates a new font, and it toggles bits within the style. It's not worth going into the details of this code right here, but the XOR operator toggles bits on and off. within that style. Let's go back to the form. Let's choose Centered. Here we call Set Selection Alignment, saying we want the text to be centered. Go to that procedure, and all it does is set the selection alignment prop to the alignment you've specified. So the rest of the work here is just dealing with buttons on the tool strip, and you've already seen how buttons on a tool strip work. Let's put this form away and look at the other one. I'll load the web browser demo. This looks like a primitive web browser. It's just a form I created which hosts the web browser control and has a status strip and a couple of tool strip controls. Let's come here and type an address and go. Notice the status strip at the bottom. It's showing us status information, and there was a progress bar that showed up as we moved to this site. I can also, up here, choose to go home, which is blank, go back. I can refresh. I can go to my search site, which also turns out to be live.com, go back, go forward. If I'm loading a page, I can stop loading the page. So these buttons provide mechanisms for working with the web browser control, and that's not our point here. We'll look at how the status strip down here does its job in this demonstration. Let's look at the form in Design View. You can see down here we have a status strip control with a progress bar control on the status strip. Well, let's see how this works. When the form first loads up, we set the progress bar's visible property to be false, so we hide the progress bar at that point. As you start navigating to a site, the web browser control raises its navigating event. Let's find that one. There it is. And in the navigating event, we set the visible property of the progress bar to be true. So at that point, it becomes visible. In the status text changed event, there we go. Here, we take the status text of the demo web browser and put it into the text of our status label on the form. When you navigate to a page, the web browser downloads portions of the page one item at a time. Every time the progress changes, it raises its progress changed event. Let's try that. In the progress changed event, we first check the maximum progress. That maximum progress might be less than 0, indicating some odd state. So we check to make sure that we are greater than 0 before we start. If we're greater than 0, then we set the value of the progress bar to be the current progress divided by the maximum progress times 100, converted to an int32 value. So we get a value between 0 and 100 for the value of our download progress bar. When the document is completely downloaded, the web browser raises its document completed event. Let's find that. In the document completed event, we set the visible property of the progress bar to be false again, so it doesn't show up once we've finished loading the document. Well, that's all there really is to this browser. It's just knowing which events there are and how to hook up code that reacts to those events. Let's try running it once more. And now let's go to a few pages and watch the status strip do its job. Here I'll go to live.com again and watch at the bottom to see what happens. We get a waiting, we get a progress bar. Now let's go to another page. Let's go to, say, google.com. And again, down below you'll see the waiting status message, and there was actually other information that popped by, and you saw the progress meter running there as well. So this sort of behavior is easy to implement because the browser control raises events that tell you exactly what's going on as it does its job. Because it does, you can add your own status strip to a web browser form and get status information as the web browser does its work.